So this is the video for section 6.1, and it's actually just the first part of 6.1, so we'll call it 6.1a. We're going to start talking about exponents and all the different rules for exponents, and this is something that'll develop all the way through math into geometry, algebra 2, and forever, essentially. So first of all, we need to kind of talk about the basics, the things that probably you're familiar with. So let's talk about the perfect squares. When I talk about squares, I think you're familiar with, that means it's an exponent of 2. And what that means is you're multiplying it by itself, right? Because exponents means that's how many times you're going to multiply. So you need to know that 1 squared equals 1, right? 2 squared will be 2 times 2, so you need to know that's 4. And these are the ones that you just need to know without a calculator, without thinking about it, just kind of spit them out. So 3 squared is 9. We're going to go ahead and fill in. And really, it would be good for you if, when you're watching the video, maybe you pause it and just see how many of them you know without a calculator. I would just pause the video and just kind of do it, fill them in, and then start the video and just compare and see how you did. So 4 squared is 16. 5 squared, 25, because remember, you're just multiplying it by itself. So 6 times 6, 36. 7 times 7, 8 times 8, 9 times 9. Oops, I don't know why I put that one twice. 10 times 10. And really, these are the ones that you should have learned when you did just your basic multiplication facts. Now, definitely through 10 squared. Absolutely. If you had any kind of a program at all in middle school, you probably should be familiar with 11 squared is 121. 12 squared, 12 times 12 is 144. And now I know we're getting into ones that are harder, but I expect you, now that you're a freshman in Algebra 1, I expect you to know these. So if you don't, you just maybe get some flashcards. You just need to be familiar with these. And I mean, without having to go off to the side and do 11 times 11, longhand. 13 squared, maybe you're not quite as familiar with that one, but if that's the case, then it's just one we need to add that you need to memorize. 13 times 13 is 169. And I'm going to go here to the right. 15 squared, probably you're not familiar with that. You could multiply it out to the side. 15 times 15 comes out to be 225. But this is one that, if you're going to stay in honors as you go through math, that's one you need to become familiar with. And I mean familiar so that you know it without a calculator. Now these, they may seem hard, 20 squared, 30 squared, 40 squared, like they're big numbers, but they're easy to do because you ignore the 0. 2 squared is 4. And think about it, if you multiply 20 times 20, that's going to be 2 zeros. Same thing with 30 squared. You would say 3 squared is 9. And again, since you're multiplying it by itself, it's going to be a 0 and a 0. 40 squared, so think of 4 squared is 16. And again, if you have 2 zeros, there you go. So even though these seem higher and they seem hard, like you haven't done them before, because they're nice, neat, small numbers, 2, 3, and 4, you can actually do those pretty easily. Okay, so let's talk about the cubes. Now, this is one that maybe you're not as familiar with, but I would expect you to know the cubes from 1 through 5. And a cube means you have an exponent of 3. And so if you think about what exponents mean, that means 1 times 1 times 1. Well, it doesn't matter how many times you multiply 1, isn't it just going to equal 1? Or for 2 cubed, if you have 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. Now, when I say I want you to know the cubes, I don't want you to have to multiply your way up. I mean, you should just know them so well that you're familiar that if I say 3 cubed, you can just automatically go to 27 without having to think out to the side, hey, 3 times 3 is 9, and then times 3 is 27. Yes, that's what it means, but you need to be very familiar with these cubes. Okay, so we've got 1, 8, 27. If I were to multiply 4 by itself 3 times, I would get 64. And again, I realize right now you're probably not that familiar, but you need to be. And then 5 cubed, if you were to multiply 5 3 times, you would get 125. So these cubes, so I don't expect you to know 6 cubed or 7 cubed or higher. I don't expect you to know those without a calculator, but 1 through 5, I do. Okay, so these are the ones, again, if you're not familiar, make yourself some flashcards and see if that helps, but you've got to know these quickly and efficiently. All right, so the actual beginning part of 6.1 And you may be familiar with this, but so this might be a review, but let's just check and see. Exponents are used as a shorthand notation for multiplying numbers. You know, or maybe I should say variables. Basically, you can multiply anything you want. And if you have this several of the same, it's going to become an exponent. So for example, if I multiply 5 by itself 4 times, that's the same as saying 5 to the 4th. And yes, I know you can put that in your calculator and get a number. I'm not concerned about that right now. I just want to talk about what exponents mean. Or on number 3, if I have negative 4 squared, that's the same as saying what is negative 4 times negative 4. Again, I know that's 16. That's not what I care about right now. I just want you to understand what exponents mean. Or if I have 1/2 cubed, that means I'm going to have 1/2, and I'm going to multiply it by itself 3 times. So on number 2, if I have negative 5 and I'm multiplying it by itself 4 times, I could write it as an exponent of 4. Again, we're just thinking about what exponents mean. Now, I want you to think about number 4 compared to number 3. Number 3 was negative 4 squared, and notice that the 2, the exponent of 2, was on the entire parenthesis negative 4. So that's why we multiplied the entire parenthesis by itself. But on number 4, the exponent of 2 is only on the 4. So it's only the 4 that's being multiplied by itself. And then that negative is out in front of the whole thing. So it's kind of like do your 4 times 4 and then put the negative out in front. Maybe I should draw a different kind of arrow. So the 4 squared part right there is the parenthesis times parenthesis. And then this negative that's out in front just gets brought over. There's the negative out in front. All right, so now let's talk about, all right, what do all these equal? Well, 5 to the 4th. Again, I don't expect you to know that without a calculator. You could put it in if you wanted to, but it's going to come out to be 625. Number 2, now let's think about it. If 5 to the 4th is 625, then I know that number 2 is also 625. However, let's think about this. If it's a negative 5, if I were to multiply a negative by itself 4 times, right, I could say negative times negative is positive. But then when I do that positive times negative, I'll get negative. And then when I take that negative times the last negative, doesn't the whole thing come out to be positive? So here's what I want you to think about. If the exponent is even, see how this was a 4? If the exponent is even, it doesn't matter if this number is positive or negative, it's going to come out to be a positive. All right, on number 3, we know that negative 4 times negative 4 is positive 16. But on number 4, notice the difference. Because of the fact that you're supposed to do the multiplication of the 4's first and get 16 and then put the negative on, that's going to be a negative 16. And I know we've talked about this before. Remember, we're comparing this to this, right? This is the one that was negative 16. This is the one that was positive 16. We've talked about that before. And then on number 5, how do I do it if it's fractions? Well, when you multiply fractions, don't you just multiply the top? So 1 times 1 times 1. And then multiply the bottom, so 2 times 2 times 2 would come out to be 8. So the green is the simplification. The red is just talking about what exponents mean. Okay, let's talk vocabulary. So that bottom number is called the base. So right here, the 10 is the base. Let me make that look a little better. The 10 is the base. And then the top number, that little superscript, okay, when it's raised and it's a little bit smaller, that's called the superscript. So in this case, the 6 is the exponent. All right, so we said the base is 10 and the 6 is the exponent. So it's just vocabulary for each part. Okay, so remember order of operations, because exponents are a part of order of operations. So in order of operations, remember the first thing that you always do is the parentheses, right? Parentheses. But then number 2 is exponents. And again, I know you've looked at this before, but after you do what's inside the parentheses, then you do the exponents, and then after exponents is when you can do multiplication or division. And remember, it doesn't matter, multiplication doesn't come before division necessarily. It just depends on what you come to as you work your way from left to right, right? Same thing for number 4, addition and subtraction. And it's not that addition is necessarily before subtraction, it just depends on what you get to first as you work your way from left to right. Again, I think that should be a review. So when I look at number 1, I've got a multiplication and I've got an exponent. Well, there are no parentheses, so the first thing I would do here would be the exponents. So 3 squared is 9. Then I can do the multiplication. 2 times 9 is 18. Okay, go over to number 2. In this case, I have a parenthesis, so I do what's on the inside of the parentheses. 2 times 3 is 6, but then that parentheses is still being squared, so then I can do my exponent, 36. So even though if you look up at the top, it shows that multiplication comes after exponents, but the reason I did the multiplication is because remember the 2 times 3 was inside the parentheses, and then parentheses always comes before exponents. Okay, on number 3, I see 2 things. I see addition and I see exponents, but I know that exponents come before addition, so 3 squared is 9. Then I can do the addition and 2 plus 9. Number 4, again, parentheses kind of trumps all else, so first I do what's on the inside of the parentheses. 2 plus 3 is 5. Now that I've done what's inside the parentheses, now that 5 is being squared to get 25. And then on number 5, again, I have exponents and addition. Exponents come first, so the 2 squared is 4, and the 3 squared is 9. Then I can do the addition and get 13. Again, hopefully this is a little bit of a review, but I just wanted to kind of go back through it as an introduction to the exponents that we're going to develop. Okay, look at number 6. It says evaluate each expression if x equals -2. So in other words, we're going to plug -2 in for x. So I've got 3. Anytime you plug a number into a variable, you always want to think about putting it in a parenthesis. So in the parenthesis is the -2, and that -2, that x, is being cubed. So if I simplify, even though there's a parenthesis, there's nothing to do inside the parenthesis, right? So that means the first thing I'm going to do is going to be the -2 cubed part. If I do -2 cubed, yes, 2 cubed is 8, but now think about it. If it's a negative, I would have -2 times -2 times -2. Isn't that going to come out to be a -8? So really it's a 3 that's being multiplied by -8. It's not 3 minus 8, because notice up here, the 3 was right next to the parentheses. So that means 3 times, there's an implied times there, 3 times the -8. And our final answer would be -24. Okay, look at number 6. So we're going to start by putting -2 in place of x. So we've got 6 over -2. And remember, anytime you replace something, you want to think about it as being in parentheses. Okay, so in this case, there's nothing to do inside the parentheses, so I'm going to simplify the exponent part. So I'm going to have 6 over, now I know 2 squared is 4. If it's a negative being squared, remember what we said earlier, if it's a negative with an even exponent, it's going to become positive, because isn't negative times negative going to be positive? So it's a positive 4. And the only thing maybe I can do here is simplify, right? 6 over 4 would actually be 3/2. Okay, so again, hopefully all of that is a little bit of a review. One thing I want to mention to you on your homework, so you're doing the 6.1 homework, and I just want to show you something. Notice that it says no calculator. Now, am I going to know necessarily? Maybe not. I might not know if you put all these in the calculator and get your answers, and you might be able to go through it quickly. I can tell you this, a lot of times when people use the calculator, they put them in incorrectly. But the thing is, if you do them in your calculator, you're not going to know for sure if you really know how to do them. And then at that point, too bad. Um, so you're not going to be able to use your calculator on these on a test or on a quiz. So the only way to make sure you understand is if you do your homework without the calculator. So that's just kind of a word of warning. It's not going to help you if you use a calculator. It's not going to help you long term, that is. Okay, so there's the homework that you should be working on and then get submitted on Canvas.